All right. Okay, so welcome back. So this is a continuation on basically linear systems. I have done videos on this before for grade 9s, and I will put up a link actually up above, okay, if you want to see a lot more examples. So this is a little bit tailored towards specific examples on linear systems, and I'm only going to concentrate on substitution. So solving linear systems by substitution. So what does that mean? Well, first, so linear systems is basically, in simple terms, if you know an equation of a line, right? So if you've studied equations of lines and you kind of are looking at this video, you probably went through grade 9, then you know that an equation of a line is just y is equal to mx plus b, but it also can be put in many different forms. So here I have a set of lines. Now, if you have two lines, you basically have created a system. So there's now two lines, and the question is, where do these two lines intersect? And there's many different ways of doing that intersection. You can do it graphically. You can just plot a line. I will put up a link up above, kind of to the introduction on kind of graphing. So you can use, for example, a tool, graph it, see exactly where they intersect. Now, there are other methods of trying to see where two lines intersect. And one of those methods is called substitution, which is the one that I actually prefer the most. So if I don't have a tool, I don't want to do a table of values, I would want to be able to substitute one equation basically into another and see where that point of intersection is. Now, lines intersect can intersect, and kind of three things can happen. Well, they can intersect at a point, right? So if you have one line, so let's say going in this direction, then another line, say going in this direction, well, they intersect at a point right here. And that's the most common case that you will see in school. Now, there are other cases. Lines don't always have to intersect. If you have two parallel lines, they'll never intersect. All right, and we'll see a case here. So that's one. Now, you can also have two lines. Now, they look differently, but they're really just the same line. They're just written in a different form. So that means they will intersect at the entire line. So they intersect everywhere. So if you have a line like this, you can have another line which kind of looks exactly the same, but it is the same line just written slightly differently, which is right on top of this line. So they're identical lines. So there isn't just one point of intersection. They basically intersect at every single point on the line. So there's three things, right? Linear system can intersect in one point. So there's one solution. They can never intersect if they're parallel lines. So there's no solution at all. And then lastly, they can be exactly the same line. And there they intersect at many different points because the lines are just on top of each other. So we'll see those here. Now, if you take these, I'm going to just erase this from the screen. I can take any of these, and I'm only going to use substitution in here. So what's the role of substitution? Like, what do we want to do? Because we have two lines, so I have one line here, and then I have another line here. So I have two lines. Now, these particular two lines might be different, might be the same, right? So I don't know exactly where they will intersect, but I can find out. And the first thing that we do is we pick a line arbitrarily. Now, when you get better, you will kind of scan the lines and see which one is better to isolate for some variable, either x or for y, whatever is more convenient. So for example, if I look at these two lines, so I'm looking at question 1, I will look at the first line and it's 3x plus 8y equals to 4. And then I will quickly scan 2x minus y is equal to 5. I like that second line. And in particular, I will isolate for y there. Because I don't have a number in front of it. I just have basically negative y. So the first step always is, when you're doing substitution, you're going to isolate for either x or for y. You choose. Doesn't matter. All right? Now, once you isolate it, you will have an equation. So if you're isolating for y, you're going to have an equation for y. So for example, if I take this line right here and I isolate it for y, I'm going to take this y over on this side and then take this 5 over on this side. And what I'm going to get is I'm going to get 2x minus 5 is equal to y. So I isolated it for y. All right, right there. I could have isolated it for x. It doesn't really matter. Now, once you isolate it, and because I used this second line, the next step is, after isolating, you will basically substitute. So you will substitute. That's why it's called the substitution method. So you will take this right here, and you know what y is. Y is equal to 2x minus 5. And, excuse me, and you will substitute it into the other equation that you didn't use. So I'm going to just substitute it back in. All right, so substitute into the other equation. The other equation. Okay, or into the other line. And why you're doing that is because you want to see where the two lines basically meet. Right, if it's at a point, for example. Now, if I substitute it back in, so what I'm going to get is I'm going to get 3x plus 8. Now I'm substituting for y. So I'm going to substitute 2x minus 5 is equal to 4. Well, now you have one equation and just one unknown. The unknown is x. So what you do next, so step number 3 is you solve for unknown. That's the next step. So sure, I can go ahead and solve it. So I'm going to take my 8, I'm going to remove these brackets here. So I just have 3x plus 8. Actually, it's 8 times 2. So it's going to be 16x minus, now it's 8 times 5, which is 40, equals to 4. And now this is why the knowledge of solving for an unknown is so important. And that's why it was introduced in grade 9, and it kind of continuously builds on top of each other. Now, if you've forgotten how to solve for an unknown, I will put up a link, all right, to the entire list that you should test yourself on. Before even entering grade 10, you should know how to do those questions. There's even a test there that you can link into. So now I'm going to collect like terms, all right? So I'm going to bring, so now next, so I'm going to bring this over. This is going to become 19x equals to, now this is 4 plus 40. So it's not very convenient. This is going to be 44, 19x. Now dividing both sides by 19, and I get x is equal to 44 over 19. Not very nice, but sometimes that's what happens, right? In school, the questions you get oftentimes might actually give you nice answers. But the reality is, nobody says that the answers are going to be nice. So now next, the final thing is, because now you know the value of x, all right? So those two lines are meeting somewhere where x is equal to 44 over 19. So the last final step right here is, you again substitute. So you substitute back to find your y, because you want to know what the answer is, and it's not enough just to know x. I mean, sometimes, I guess it depends on the question, but in this case, let's try to find out what y is as well. So now, where do you substitute? You know what x is, that's right here. My original question was, so if I take these, let me just erase this, clean it up. So I had those two lines. Where do you substitute for x? Like, do you substitute here into this equation and solve for y? Do you substitute in here to solve for y? Or maybe do you substitute in here, since you already have y isolated? The answer is, it doesn't matter. You substitute into any of them to try to find what y is. So I will pick actually this one because it's the most convenient. It's already isolated for y. So I'm going to just say, so this is y equals, and it's 2x minus 5. So it's 2. Now I know what x is. So it's 44 over 19. And I forget they're minus 5. All right, minus 5. So that is, so now 2, I'm going to multiply it through. So that's going to be 88 over 19 minus 5. And sure, you can find a common denominator. All right, remember 5 is just 5 over 1. And then find whatever your answer is. So you can use fractions. Again, it just keeps coming back, right, to the things that you should have known before grade 10. So, I mean, I can just pop in, okay, so in here, sometimes you might be lucky, you know, that you can just use directly, you know, your calculator, which has the fraction buttons, and then you'll get your answer, right? So it's negative 7 over 19. And I encourage you to try to do it, right? You can set the denominator as 19 and then find out what that answer is. Now, what does this mean, right? So finally, like, what does this mean? Well, this means that these two lines are going to intersect at the point 44 over 19 and negative 7 over 19. That is the point where these two lines intersect. So if you would graph them, or whatever this is, this might be coming from a word problem, which you will probably get in grade 10. Okay, some word problems that you have to set this up. And it has a meaning. Now in this case, because these are two lines, the meaning is they're intersecting at that point. So let's check it out. I mean, we can definitely graph these things, so to try to see. So now let's, my terrible, so 3x plus 8y equals to 4. So let me graph this. I'm going on decimals here. So 3x plus, there you go. That's my memory of a goldfish. 3x plus 8y equals to 4. 8y equals to 4. 8y equals to 4. So that's one line. And now the other line, if I go back, 2x minus y equals to 5. So 2x minus y equals to 5. All right, so notice that's where they intersect. All right, now what point is this? So it's 2, now it gives it to us as a decimal. And that's why when you use graphing tools, they'll approximate for you. This is not the exact answer. When you use substitution, that is exactly what the answer is when you leave it as just fractions. So it's 2.316, right? Now what was that? So I mean, here, if I change it back to decimal, okay, and then graph it, so notice, negative 0.368. So yeah, that's exactly what it is, right? And then it was what, 44. So let's put that, 44 divided by 19 here. And that's what it is exactly. So that's how you use substitution in order to find your answer. So first, step 1, you isolate for whatever you like. You don't have to pick y, you can pick x. You can pick whatever equation. Then you substitute it in the opposite equation. And then finally, you solve for your unknown. And then you substitute to find the other one. Now, the last method, which sometimes you may be asked, and you can use this for yourself, it's called a check. Okay? What is a check? When you're doing a test, right? I mean, I checked because I used graphical tools now to check my answer, right? So computer does it for me. Computers are, in some cases, better than us, right? We are very prone to error when computers are written, okay, in terms of programs. I mean, they still make errors, but they make less errors than us, okay, oftentimes. That's why artificial intelligence kind of slowly is taking over certain things. So now, what is a check? Well, the check is, I know what my answers are. My answers are these. This is x, this is y. So on a test, if you have time, or sometimes if you're asked, you can literally take the lines here, so these two lines. Okay, so you can take these. So let me copy. And, okay, so I'm going to paste it. You can take one of the two lines, or both lines even, and you can substitute for x and y, and then see if it gives you the answer. All right, so here, I'm going to just show you what I mean by that. So let me take the first line. So the first line is 3 times, now it's times x. So and x is 44 over 19. And then it is plus 8, all right, times, and this is negative 7 over 19. So that's on the left-hand side, right? That's the left-hand side of that first equation. Now I'm going to hit equals, and notice that it equals to 4, which is the right-hand side, which simply means that my left-hand side equals to my right-hand side. That's a check. So when you're doing a test, and let's say you can't use calculators or some graphing tools, you can kind of plug in your answers back in, and you can use the first line or even the second line if time allows you, just to make sure that your answer is kind of right. So that's called a check, okay? That you're plugging it back into the original to see if it makes sense. So that is it. Now that's a long explanation of the substitution method, but I think it's worthy. You know, you can try it for yourself and see these questions. Now, let's try some of these other questions. So I'm not going to take that much time. Now I'm actually going to just solve it. So let's copy, and I'm going to start solving these. You can do your checks if you like for this. So again, I have 2 equations, right? Notice that the first equation is already isolated for y. So don't waste your time and start isolating for something else. If it's already isolated for you, great. Step 1 done. Second step is let's substitute it back into now the other equation. So I'm going to take this equation, substitute it into this. So now my substitution, so I have 4x plus 2. My y is 3 over 2x minus 2. So I just substitute it in there. Minus 10 is equal to 0. So I just substituted it back in. Now I'm going to solve for x. So I'm going to get rid of my brackets here. 4x plus, now 2 times 3 over 2 is 3. Okay, you can check that. The 2's will cancel. That's going to be 3x. Minus 4 minus 10 equals to 0. So this becomes 7x. Notice the negative 4 and the negative 10 you can bring over to the other side. And if you bring it over, it's going to be plus 4 plus 10, which is 14. Now dividing by 7 on both sides, I get x is equal to 2. All right, so that's what I have. And now next, okay, so my answer, so in terms of what is y, because again, I was already, so right here, I've already isolated it for y. So this is 3 over 2, okay, so this is 2, minus 2 equals, and now I can find out what my y is. Well, the 2's will cancel, so it's just 3 minus 2, which is 1. So my answer overall is, this is the point where the 2 lines will intersect. And now I can do a check. Now notice, when you're doing a check, so above I said, you know, you can use the 2 lines, right? And then substitute it back in. Now sometimes it's wise, if you used one of them, so notice I've already used one of them here. So that means your check, so if you're going to do a check for yourself, you might as well use the other line to check because you've already used one to actually solve. So that means, let me use this one. So I'm going to say 4. Now x is 2 plus 2, y is 1. And that's supposed to be minus 10, and we'll see if it equals to 0. So that's 8 plus 2 minus 10 equals 0. Yep, 0 equals 0. So we say left-hand side equals right-hand side. Okay, check completed. Now, if you want more checks, you know, like depending on what you guys are doing, so maybe open book test or something, project, whatever, graph it, right? I mean, you can use table of values to graph it, or you can directly graph it on decimals, for example, or any other equivalent tool. So this is 3 over 2x minus 2. So y is equal to 3 over 2 x minus 2. So that was one of the lines. And then the other line, 4x plus 2y minus 10. So 4x plus 2y minus 10. I'm so worried I'm going to forget these things. It's kind of crazy how my mind is when I'm making these videos. My memory is not the greatest. I don't know why that is. But anyways, here's where they intersect. Notice 0.21. There you have it. All right. I mean, having a tool like Desmos is crazy. You know, when I used to do this, there were no tools like this. You know, if you go back, whatever, 30 years or something, I mean, you would have to pay a lot of money to try to get kind of graphing calculators to do this. Now, I mean, this is free, right? And I'm sure that there's other tools that you can use for graphing. So those are two examples that we have done. I know this video carries on, but I hope it's worth watching. You know, you're going to be able to learn a few things. I don't want to go very quickly, okay, on the material, especially on the next two, all right? So here we go. So now let's take this example, okay? So this is our next example, copy. And you're going to be using substitution method again. So let me scroll down, paste it. Here it is, all right? So what do I do, okay, for substitution? Again, I have to isolate for one of them. Now, it doesn't matter which one you pick. Now, I'm looking at this, and the first equation, I have 2x plus 3y equals to 0. Now, the second one is 2 over 3x plus y is equal to 3. So notice, it's already kind of isolated for y. Okay, so I'm going to pick, you know what? I'll pick whatever. I'll pick the first one, okay? And I'll isolate this. Let's isolate it for x, because we've always done y. I just want to show you it doesn't matter. So if I isolate this for x, so I'm going to get 2x. I'm going to bring that 3y over to the other side, so it's going to be negative 3y, plus 0, which is still negative 3y. Now, dividing by 2, so I'm going to divide this by 2. I'm going to get x is equal to negative 3 over 2y. Now, once you've isolated it for x, so what you're going to do is you're going to take this and you're going to substitute it back into the opposite equation. So that's why it's called, again, the substitution method. So if I'm going to do that, okay, if I substitute it, I'm going to get 2 over 3x, this, okay, plus, now y. Now y is negative, there you go, I blew it, because I was so used to isolating for y. So I got to be careful here. So now I've isolated it for x. So this is 2 over 3. Okay, let me substitute for x. Negative 3 over 2y plus y is equal to 3. Okay, so this is what I get. And now, so, I mean, this is kind of nice. So 2 cancels with the 2, 3 cancels with the 3, and I get, so this is negative y plus y is equal to 3. I have a problem here. I have a problem. Because negative y plus y is 0, right? It's 0y. So I can't really solve for y, because I can't divide this by 0. Y is going to be equal to 3 over 0. That's undefined, right? But what does undefined mean? So what has happened here? Basically what has happened, this is telling me that there is no solution. This is telling me there is no solution. There is no point of you going any further. No solution. If you do not get a unique number out for y or for x, and you get something like this, it means there's no solution. Now, what does that mean intuitively in terms of lines? Like, when do lines have no solution? Meaning, when don't they intersect? When they're parallel, right? So these are just parallel lines, and they will never intersect. So that's why there is no solution, and the math tells us that. All right, now let's graph it. So if I take this, so 2x plus 3y, so I'm going to graph this. So 2x plus 3y equals to 0. So there you go, that's that line right there. And then my other line, which is 2 over 3x plus y, 2 over 3 x plus y. This was supposed to be 3. Okay, so there you go. Parallel lines. There is no intersection. And that's what's going to happen when you use the substitution method. You're going to run into a problem where basically when you're solving towards the end, you're going to get something like this. 0, because negative y plus y is 0. So really, it's 0 equals to 3, which is impossible. So there's no solution. So be mindful of that if that happens to you. Now, here's a contrast, all right, for the last example that we have. So here's the last example. Copy. Just want to show you what happens here. All right. And then we're going to finish off that video so that you can try these on your own. All right. So I have y is equal to negative 2x plus 3, and then 4x plus 2y equals to 6. So first I got to isolate for something. Now it's already isolated for y, so I'm not going to waste my time. All right, and neither should you if this was on a test or assignment or something. Unless you're told otherwise, you know, like isolate for x or something. So I'm going to take this y and I'm going to plug it in back into the other equation. So what am I going to get? I'm going to get 4x plus 2, and then I'm substituting back in for y equals to 6. So this is going to be 4x. Okay, I'm going to distribute this through. So this is negative 4x and plus 6 equals to 6. So 4x minus 4x. Well, that's 0. Now that's 6. If you bring it over to the other side, you're going to get 6 minus 6 on this side and 4x minus 4x on this side. So you're going to get 0 equals to 0. All right? Which is different than what we had above. It's different than this. This can never happen. 0y equals to 3 is never true. So there's no solution. But 0 equal to 0 is always true. What does that mean? Right? What does that mean? So once you get to this point, what's the meaning? Because I can't solve for x because it gave me 0 equals to 0. This is something that you have to think about in terms of if these are two lines, what actually happens is, I mean, I don't know how these, I guess it's negative 2x, so it's kind of going like this, right? The slope is down. So that means that that's kind of this line. And then this line right here is basically the same line. Okay, it's going to be the same line which is right on top of this. Which means, where do they intersect? At every single point on the line. So the solution, the answer actually, if you want to be really precise, well, the solution is y is equal to negative 2x plus 3. It's actually the entire line. That's where they intersect. Because they're intersecting on every single thing. So now, and check it out. If you take this, so if I have 4x plus 2y is equal to 6, let's isolate it for y, right? Because this is what we had right here. If we isolate it for y, we should get back exactly this, our first line. So I'm going to have 2y equals 2. So negative 4x plus 6, right? If I shift this over. I'm dividing by 2 on both sides. So it's going to be negative 4 over 2x plus 6 over 2. So that's by the division. And indeed, if you now simplify this, okay, so this is going to be 4 over 2, so that's just 2. So 2x, and then this is 3. So there you go. These are exactly the same lines. Same slope, same intercept. And that's what's going to happen to you when you do the substitution method. I don't know if this is always taught in grade 10 or not, but I think you should know it. Because at some point, you know, you might run into it. Maybe if you have a teacher like me or something, or a prof like me. Or if you're doing research, you know, these are good because they kind of tell you, you know, what the meaning is. So again, to summarize, these linear systems. So a linear system just means a set of two lines where you want to find where they intersect. They can intersect at a point, as we saw in the first two examples. They can intersect, okay, at every single point of the line, like we saw here in the last one. They're just lines on top of each other. Or 3, they never intersect. They're just parallel lines. And then, you get something goofy looking like that. All right, so that's the substitution method. I hope you found this video useful. Sorry that it's a little long, but if you really want to learn, I hope that you kind of grind it through instead of just fast forwarding. Okay, we'll see you in a future video. Peace, everybody. Take care. Bye.